Alright, here's a video related rates question. We're going to take a look at this assignment here. We're going to take a look at number 4 here right now. So number 4 reads this: how fast is the edge length of a cube increasing when the volume of the cube is increasing at a rate of 144 cubic centimeters per second and the edge length is 4 centimeters? So remember, with related rates we need two rates that are related, and we usually have at some some point in this problem that we're going to calculate one of those missing rates. So one's going to be given, one's going to be missing. What do we got here? Well, we're talking about a cube, so the other thing you might want to do is draw a little diagram. I always encourage you to sketch a little diagram so that you can kind of have a bit of a visual. And I'm going to make this cube, side lengths are L, okay, so lengths of the side. Now it says, how fast is the edge length of the cube increasing? There's a rate, so we're going to be looking for L prime. Don't know what that is. That's our first rate right there. When the volume of the cube is increasing, oh, here we go. We have another rate, both increasing, both positive then. And what is it? The volume is increasing. So volume is going to be our other rate in this problem. And it's given. It's increasing at a rate of 144 centimeters cubed per second. Now, I don't usually write the units, but I want to show you that the units have to line up in the question. That you may be given something wonky here where you've got centimeters here and you've got meters here or something. So you just have to be aware of that. So I'm going to write out the units here for this one. So at what stage are we calculating this, determining this instantaneous rate of change? At what instant in time? Well, that instant in time is usually given as a length, okay, or at a distance of some point, not as time, but as distance. So at the edge length at L equals 4 centimeters, okay? So you just want to make sure centimeters and centimeters line up, and here's all your given info, okay? So now I'll erase this, and yeah, so that's where we're at. Okay. So the next thing you want to do is you want to create an equation that relates volume of a cube and side length. That's easy, super easy. Volume is the side length times itself 3 times, or length cubed, and that's as good as that. There's an equation, relates the two rates. There's no other variables in there, quantities in there that are going to mess things up. So this is easy. Now we differentiate. So with respect to time, the derivative of v is v prime. The derivative of this with respect to time is 3l squared. You treat this, you leave this variable alone at first, but then you remember, hey, it's with respect to time, so this is not the preferred variable. So now I need to multiply by l prime. Say chain rule. Okay? So implicit differentiation, whatever, it's with respect to time, so differentiate all variables that you have in there. At this point now is when you start substituting. Do not substitute before you differentiate. Very, very important. So what do we have? We have v prime is 144. We have the 3 we'll leave there. Let's skip over this for now. L prime is unknown. Okay, L prime is unknown, so that's going to stay as L prime. We're going to solve for this. Now what about L? Well, remember, L is 4. So let's plug in 4. That's at 4 squared. Okay, so L prime is 144 over 3 times 16 is 48. So L prime is 3. Now what does that mean? 3 what? Well, you go back to your problem here. Centimeters is the length and time is seconds. So this is what you say with a nice finished sentence, so you can tell your teacher you know exactly what the question is asking and you know exactly what your answer is. You say the length of the side of the cube is increasing at a rate of 3 centimeters per second when the length of the side is 4 centimeters long. Okay, so don't get this confused. Don't say, hey, I've got 2 different answers here. No, this is your answer. This is the rate you're looking for. Okay, so how fast is the edge length increasing? It's increasing at a rate of 3 centimeters per second. So there's your answer, and yeah, I hope that helps question number 4.